Hello everyone and welcome to Contemporary Math. This is going to be section 2.3, Operations with Sets. So operations are kind of like adding and subtracting, multiplying and dividing, but with sets there's a few different things that we can do. So the first one we're going to talk about is the complement of a set. Now the complement of set A is going to be symbolized by A prime. Okay, so it's just an A with a dash there. Now it's going to be all the elements that are in the universal set that are not in set A. And so this is a way we can write that in set builder notation. So it's all values such that the values are not in A. So very quickly, if we're looking at a Venn diagram of this, here's our universal set. So that's everything. Here is set A. And so what we're really looking for when we look at A complement is everything that's not in A. So it's everything on the outside here. So all of this stuff is A complement. So looking at our first example, here we have a universal set, and it's the integers from 1 through 10. Set A is defined as 1, 2, 4, and 6, and B is 2, 5, 7, 9, and 10. So the first example says find the complement of set A, or find A prime. One way you can do this is by starting with the universal set. Okay, so if you're very tactile, this is a good way to start off. So here are the elements in the universal set, and what we're going to do is cross off any element that is in set A. Okay, so 1 is in set A, so we're going to get rid of that one. 2 is in set A, so get rid of that one. 4 and 6. Now everything that remains is going to be in the complement. So we'll just rewrite this now. So we have 3, 5, 7, 8, 9, and 10. All right, let's try the next one. So for example 2, we want to find the complement of set B. So it's everything in the universal set that is not in set B. So you can do the same process again, but you can just do it in your mind if you'd like. So B contains 2, 5, 7, 9, and 10, so we just can't use those numbers. Okay, so we got 1. We can't use 2, so we do 3 and 4. We can't use 5, so we'll do 6. We can't use 7, but we can do 8. We can't use 9 or 10, and so that is B complement right there. All right, let's move on. Deal with the intersection. So the intersection of the two sets, A and B, is written like this. Okay, and it's going to be the elements that A and B have in common. Now the word that gets used here is the word AND. So A intersects B with all the values of x, such that x is an element of A, and it's also an element of B. So that's where that word AND comes in. And you can remember, okay, this symbol almost looks like an A standing for AND. Okay, so it's those things that are in common. All right, so here we have two sets, and if we're going to find the intersection, we want to see what do these two have in common. Okay, so if we were going to look at a Venn diagram of this, here's our universal set, and now we have two sets, and they could possibly overlap. Okay, so here's set A, and here's set B. And if we're looking for the intersection, we want to see what they have in common. So the place they have in common is right here in the intersection. So let's do number 3 here. We want to see what do these two sets have in common. What is their intersection? Well, 3 only belongs to this set. It is not in this set, so it's not in the intersection. 4, the number 4, belongs to both sets, so that is going to be part of our intersection. 5 only belongs in this set. 6 belongs in both sets. So we're going to write that one down. And then 7 is only in this set, and it's not over here. Now notice there's a couple other numbers, 8 and 10, that are in the set on the right, but they're not in the set on the left. So we leave our intersection with 4 and 6. Okay, so problem 4 here. We want to see what do these two sets have in common. So 9, 14, 25, and 30, 10, 17, 19, 38, and 52. Were there any repeats? Is there anything in common? So in this case, there is nothing in common. And when that happens, all we have to do is write the empty set or the null set. Okay, can use either one of these notations there. Now number 5 says, what is the intersection of 5, 9, 11 and the null set? Well, since the null set has no elements, then there can be no elements in common, and we would get the empty set or the null set again. Alright, number 6, we were given two sets, A and B, and it says find the intersection. So you're probably getting the hang of this. You can try it now. As I'm looking at this, what do I see in common? Looks like 2 is the only thing. So it's the set that contains 2 right there. All right, let's move on. Next we're talking about the union. So the union of sets A and B is written like this. Now it looks like a U. Okay, so union and U. It's the set of all elements that belong to either set A or set B. So now the word is or. If it belongs to set A, it's in the union. Or if it belongs to set B, it's in the union. And we basically want to think about uniting the two sets. So we're going to draw our Venn diagram again. So here's the universal. Here's set A, here's set B. So we're going to end up uniting both of these sets. So here's set A, and here's set B. Now notice the intersection kind of gets shaded in there twice, but when we write the union, the set, we only include those elements one time. So for example 7, it says find the union of the given sets. So all we need to do is take these two sets and put them together. So we'll just start off with this one. We have 2, 4, and 6. And then we're going to add to it 4, 6, 8, 10, and 12. But we don't need to repeat any of the elements. So 4 is already there, 6 is already there, so we're just going to add on 8, 10, and 12. And there is the union. Now number 8, we're uniting 3, 4, and 5 with the null set. So again, if we follow that same process, we're just going to take our first set, 3, 4, and 5, and then add to it any elements in the second set without duplicating. So the null set has no elements, so there's nothing to add. We just got 3, 4, and 5. Alright, so hopefully you have the hang of this. Try number 9. You can either try it with me or try it on your own there. All right, so here we get 1, 2, 4, 6, 5, 7, 9, and 10. So the 2 was duplicated, and we only need to use it once. Now, is it wrong if I put 5 out of order here? Okay. No, it's not. So a set is just a listing of elements, and the order of those elements doesn't matter. Typically, we like to see things in order, but this would be just fine. And that brings us to our final operation we're going to be talking about today, the difference of a set. So here, the difference of a set, written A minus B, is the set of all elements belonging to A and not to B. Okay. Now in this one, this is the only one where the order matters. Okay. When you're dealing with complement, union, or intersection, the order doesn't matter, but this one does. So we have A minus B, so it's every element in A, and those x's, those elements, cannot be in B. Okay, so let's see what that Venn diagram is going to look like here. Universal set A and B. So we want only the elements that are in A but are not in B. So if I'm looking here, everything there is in A. Now notice there's elements here that are in A, but those are in B. So we can't use those. So we think about that subtraction as the set B takes away from set A. And so this is what we're left with here, A minus B. All right. So we want to find the difference of the following sets. So we have the set here, the numbers 1 through 10, minus 2, 4, 6, and 8. So one way you can do that is by simple crossing out. So we're going to subtract 2. So we're going to cross it out. We're going to subtract 4. We're going to cross it out. 6 and 8. Now everything that remains here is in this first set, but not the second. And so we're left with 1, 3, 5, 7, 9, and 10. Now if we move on to question 11, we have dogs, cats, and rabbits minus cats and mice. Okay, so we're subtracting cats out of here, but what do we do with the mice? Do we get negative mice? Well, the answer is no. When we're dealing with set theory, we're not using our normal number rules in thinking about these. We have to think about sets as a set of elements. And so if that element didn't exist in the first place, subtracting it is not going to do anything. So thinking about this, we're going to be left with dogs and rabbits. So where would the mice go in that Venn diagram? Okay, so it was in our set B, but it was not in our set A. So the mice would have gone right here. All right, so example 12, you can try this one on your own and check back. All right, and this should have given you the set with 1, 4, and 6. All right, that's it for our operations with sets. Thanks for watching.